Okay, now it's working. What's up, everyone? My name is John. I'm a software engineer with about 10 years of experience. I'm the lead organizer of Laterally, an open source educational community, and I'm the author of the Laterally leetcode kata and other technical interview preparation materials like the 5 to 23 patterns article and more. Today, I'm actually going to try to perform the leetcode kata, and I expect to bomb, okay? And I'm hoping that that's a reassuring message to you, where it's like, man, this guy wrote the leetcode kata, but it still takes like many iterations to like get good at it. The good news is once you're good at it, you kind of can maintain that. But someone like myself who's like hasn't been interviewing in 2 years, I'm hoping to show you a series. I think I can get back into flow in 5 sessions. So this will be the first session, and I don't know, I might get through 3 or 4. I'm only giving myself 30 minutes today. You know, if I was really in a grind, I might be at this for hours. But I'm going to time box it to 30 minutes, and we're going to see how far can we go. We'll do another one tomorrow, and then it won't be every day, but probably 3 weeks, probably 2 a week for 3 weeks, and we'll get through 6 of them and see where we're at. Okay. So the first, and we're doing the standard kata, which is 12. There is an expanded kata of 21. I think it's 20. Yep. So that's a typo. So here is the standard kata. Let me quickly go over to Laterally and mark an issue, which is typo in kata blog. At one point, it says expanded has 21 problems, but it's 20. Okay. Cool. So 2 sum 2 is the first one. All right. Let's clear this out. And I'll do this in Python, although you can, well, I guess I need the signature. Okay. Given a 1 indexed array of integers that's already sorted in non-decreasing order, find 2 numbers such that they add up to a specific target number. In this one, we can use the window. Okay. So I need to set up a, I'll eventually return the array. I guess I'll return left and right. This will be left IDX and right IDX in contrast to the left and right values. Okay, so we can do a while loop. We'll start off with left IDX equals 0. Am I guaranteed that there are of length? There's a minimum of 2. We're gonna do this. Constraints is 2. Okay, so it'll at least be 2. And so I'll just say if the length of numbers is 2, return, we can do this down here. Return, actually I don't need to do that because it'll just fall through the right. While left IDX is less than right IDX plus 1. So with that constraint, if there's only 2 of them, it should fall right through because 0, 1, it's not less. Thanks for the likes. Okay, so there's the left IDX, and then the right IDX is going to be the as far as you can go. Okay, So let's slide this window. If, and then we need the target, and then we have cur sum. And then if cur sum is less than the target, we move one way. Else, elif, we'll move the other way. And then there is a condition where we just go ahead and return. So we'll have two return locations. That's fine. So if the current sum is less than the target, we want to increase the sum. And given this window, we already have the right hand as far to the right as it'll go. So the way that we increase the sum is we move the left hand in. So left idx plus equals 1. Okay. Else, if the current sum is greater than the target, right idx minus equals 1. And then otherwise, we're at target. Okay, let's see how this goes. And what time am I at, by the way? I didn't time on this. Cur sum is not defined. Cur sum is left plus right. Left is numbers, look up the left index. And right is numbers, look up the right index. Wrong answer, okay? Expect output 0, 1, expected 1, 2. Do I have an off by 1 issue? Oh, it's one index, given a one indexed array. Okay. Add 1 because 1 indexed. I think we can just add it at the end. I don't think we need to modify the logic throughout. All right, cool. So that is the first problem in the kata. Oh, it looks like we're at the 8-minute mark currently, although that was with the intro. So I'm not sure how many minutes I spent on this, but I did want to say that my goal is to cap each problem at 5 minutes. And if you don't get it in 5 minutes, look at the answer. That is a very short cap. If you're trying to learn deeply in a non-kata approach, so kata is a memorization approach. So memorization over deep learning in this approach. And actually, it's more like memorization enables deep learning, because once you can do everything very quickly, you kind of remove some stress and you can kind of think more freely is the notion here. But really, they're not alternatives, they're complements. So you should be learning deeply and applying kata. And the article goes into this, by the way. But for these problems, for the kata in particular, a 5-minute cap, where if you were trying to do deep learning, I might say hang in there for 30 minutes or even an hour on a single problem. Although you start to hit exhaustion around that point. So I think an hour is not good in any case, but 5 minutes. Okay, the next problem is threesum. So the thing to remember about threesum is that it's 2-sum with a wrapper. All right, is this one indexed also? These look, the examples all look non-decreasing. Is it guaranteed to be non-decreasing? Given an integer array nums. Yeah, I've seen that in a real interview. I think I saw it at Amazon. Given an integer array nums, return all the triplets. I don't see that it's guaranteed non-decreasing. Oh, and I didn't even read the example right. So that I thought it said 4. So they can definitely be shuffled up. So we should use so that we have two options. One is that we can sort it because this is threesum. So with 2-sum, when the inputs are sorted, you can use the sliding window and get O of n. So O of n plus a wrapper would be O n squared, which is slower than a sorting algorithm at n log n. So I can sort them if I want to. And if I sort them, I'll do the sorting, then I'll get O of n squared. So I'll get O of n squared either way. So it doesn't necessarily make sense to sort, but the time complexity target is O(n) squared. Here, let me do my parentheses, O(n) squared. And I didn't say it for the last problem, but it was constant. It was constant time. Space complexity. Theoretically, you could do an in-place sort and get constant space complexity, but I'm going to use a hash map. So I'm going to go for O of n with a hash scene cached map. So that's my high level approach. Possible improvement is O1 space O1 space if we sort in place. Okay. So, and then the overall strategy, optimal two-sum with a O(n) wrapper loop. Okay, so that's the strategy here. So to do that, we're going to go implement two-sum. And then I'll give it the same well, it definitely gets the same argument. Does it get the same return value? Yeah. It will return it doesn't return a list of events. It just returns a list of events. It's going to give you those two indices, right? I could even have it return a tuple events if I want. It should just be the two. Okay, so we'll go with this. So for two-sum, and then here we will do for value in nums.values. Where's the rest of my signature? I'm expecting a target. Why do I not have a target? Such that I not equal j and I not equal k. Oh, the target is 0. Okay. Okay, target is always 0. So let's do scene equals this dictionary. Now I want to know what. Oh, so the two-sum target should always be the opposite of the current value. Okay. So here's self-nums target, which is an int. And then if two-sum value or nums, let's see, nums value target this will just be nums minus value. Return the triplet. And then what if I get down here? What do I return? Hey, King says, what are we building? We're just doing LeetCode today. Just, thanks for being here, King. Just Smile says, hello, what do you think of iOS native career dev? I think it's a fine way to break in. I wouldn't want to restrict myself that way long term. But yeah, if you want to work your way up to senior that way, that's a great specialization. And then maybe from there, you want to broaden out. Frankly, I recommend full stack all the way across the board. There's going to be way more job opportunities for full stack compared to iOS native dev. But if you have like a passion for it or a portfolio build up, maybe you've already built that thing. It can be a tool. It can be a tool. I would strive for full stack anyway. Even if you're pursuing those jobs, I'd strive for full stack. Struggling between iOS native or Java backend dev, then you should. Then you're already. Then the answer is already you should be full stack. Because if you're going to do the backend and the front end, you should go full stack. And sorry, did I lose you? If you're struggling between backend and front end, the answer is do both and go full stack. And when you go full stack, I recommend you start with front end. It's easier to learn front end. Although iOS native is like the hardest kind of front end. So go for it if you're really passionate, but I would start with web development using React. And then as a second step, I would go React Native for mobile. And I wouldn't restrict myself or pigeonhole myself. I would just add it to the repertoire. So broadening my skills rather than pigeonholing. Okay, we're going to give this one more minute and we're going to look up the solution. So this is not clicking fast enough. So there's a scene map over here. This is not sorted. So scene, and then I can call, yeah, I don't need a scene map over there. So for, we'll do we can sort and do left and right pointers, or we can just do the scene map. So for the scene map approach, for key value in nums is not an object, nums is a list. For IDX value in iter nums, what I'll do for now is just print. And we can just make sure that we are kind of like in the right ballpark. And then what's going to happen is here we will return empty. And Python interprets the empty list as falsy. So it would fail this check. And what happens? Are we guaranteed to get an answer? It seems like we're guaranteed to get an answer. Oh, here's the empty set. The only possible triplet does not sum up to 0. Okay, great. So this is what we do in that case. How good is leetcode for learning a new language? Leetcode is an awful way to learn a new language, I think. I mean, I guess it depends on where you're coming from. If you're already like pro at leetcode and you understand the problem space very well, then the leetcode problems become your pet problems and it becomes a good translation mechanism. But in my experience, that's pretty rare. And typically we understand products, we understand things, we understand blogs, we understand websites. And so those are better pet problems. And so those are better translation mechanisms from language A to language B. You re-implement the pet problem in a new language. That's like a really good translation way to learn. To reuse your skill. There's a word for that. Transfer your skill, something like that. Okay, so let's look up the solution. We're going to look for Python 3. All right, so res is a set. Well, I didn't use a set. This is not at all what I had in mind. So I'm going to cancel that. Brute force to optimized two-pointer solution. So here, this is also not what I had in mind. So they're not splitting out the two sum. For IDX in range 0 to R length, if IDX is greater than 0, So they just sort it right out. Okay. Is that just because it makes it easier to work with? So 2-pointer, and they don't talk about the time, the space complexity. Time complexity is n squared, right? Yep. While j is less than k, so this is like while left is less than right. If sum is 0, res append. So this is basically 2-sort in here. So this is kind of like what I had in mind, but they sorted it. Let's go to the editorial. Okay, so we're always going for 2 pointers. I didn't think about that. BCR O n squared, I did that. Thanks for the follow. If you're wondering how to solve the problem without sorting, go over the no sort approach. There are cases where it's preferable and may probe your knowledge there. Yeah, so I was thinking of no sort. O n squared, space complexity O. Yeah, so this is what I was actually going for, was the no sort. See, it looks clean. Even here, they didn't break out the 2 sum. Even here, they didn't break out the 2 sum. Okay. If val not in dupes. Ooh, I didn't have a duplicate check. Use another hash set dupes to skip duplicates in the outer loop. Without this optimization, the submission will time out. Okay, so let's implement this. So although I should be using 2 pointers, so that's something to remember. 3 sum should be, has 2 solutions, no sort, and 2 pointers. And the 2 pointers is going to have the O1 memory. Is that right? Space complexity is O log n to O n, depending on the implementation. So it's going to have a lower memory requirement, even if it doesn't get to constant space. And 2 pointers has no sort and 2 pointers. Better, preferred, because lower mem. Okay, great. So for no sort, we want a result set. So it's returning it as a set. That's interesting. And the set still comes as a list of lists. That one is interesting to me. So the set can be viewed as a list. I mean, abstractly, I get it, but I thought from a type perspective, it wouldn't do that. All right. Res dupes is set. And then here's scene is a hash. Okay. For value, let's see, do we actually use I? Okay, so we want the I as well. For I value 1 and enumerate nums. How would you build a form in Angular that 3 components need access to? I don't get it. You just define a component, right? Is that complicated for some reason I don't understand? You can use that. You can use a form component and multiple other higher order components if you want to. Enumerate nums. Okay, if the value not in dupes, how would you share it? You can just import it, right? Dupes dot add. Okay, so you're not going to be able to see that duplicate again. Where does val2 come from? We're defining val2. So this is the inner loop to sum. Okay. I actually like to extract this into a helper. That's okay. In one form over 3 tabs, each tab can update it and should stay updated. One form over 3 tabs. Oh, that's very, 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 very different. So having 3 components access it is very different than having 3 components access it across different tabs. Yeah, that's more complicated. There are ways to do it. The first way that I think of is sockets, but that's not optimal. But you could have your component listen for sockets, and then anyone can push a socket, so they would all receive the update. If you're working in Chrome, then you need to know your browser set limitations, right? If you're working in Chrome, there's better APIs that you can do locally in Chrome, where they can all listen to like a Chrome context, basically. That's not what it's called, but that's the idea. Wow, this is awesome. Thanks for doing this. Very, very welcome. Okay, so anyway, let me finish up the problem here. Hey, happy to chat with you on the Discord if you want to chat through that some more. It's going to depend on your browser set limitations, basically. Okay, jval2 and enumerate. Are you preparing for an interview? I have an interview coming up, yeah, but really this is just for like the community. So I made the leetcode kata. Here's the kata. And then I just want to show people that like it's okay to struggle, you know? So it takes time, as you can tell. Like I'm only on the second problem after 30 minutes. So the goal is to be able to do 12 problems in under an hour. But if it takes you an hour to do 2 problems the first time around, like that's okay. That's totally okay. So yeah, I'm going through an interview loop just because I like to like try my own stuff. I like to make sure the advice I'm giving other people works. But even if I wasn't, you know, I'm doing this for the community, really. How would you clone a nested object? What are we doing here? You can use deep copy in Python if you want to, but that's not going to work in JavaScript. In JavaScript, the way that I typically like to do it is JSON serialize, deserialize. That has caveats like you need to ensure the entities under clone are all serializable. But you know, if you want to do a shallow, so you ask for a nested object, right? Because another common pattern is the shallow clone with the ellipsis, but you can't do that for a deep clone. And then there are libraries, right? You can break out libraries for deep cloning. I mean, underscore is a popular one, but I really hate installing underscore. What does serialize mean? Stringify? Yeah. Stringify is the JavaScript DOM term, but serialize is like the abstract term of converting an in-memory data structure into something that's going to go over the wire, over the network. So that could be binary, that could be JSON, XML, whatever. But yeah. Why do you hate underscore? Too big? Yeah, it's basically nothing in underscore. There's basically nothing useful in underscore. You can pretty much implement it all. In 2023, there's like ES6 native ways of doing everything in underscore. It used to be useful, but it's like jQuery. We've like implemented everything natively now, so you don't need to install it. It's extraneous. It's extraneous. What are the drawbacks of, okay, I'm going to try and finish up this problem. It's a fun quiz in the chat. I don't know if you're like trying to quiz me or if you're actually asking. But yeah, come over to the Discord if you want to know the drawbacks of Stringify. I already told some of them, right? Like all of the entities under cloning need to be serializable, so that's a limitation. Actually asking, yeah, the main drawback is that it just doesn't work all the time. So all of the entities under copy need to be serializable. And then if you have an entity which is pseudo serializable, so I can have a class that allows itself to be serialized to JSON. But if I stringify that and then if I hydrate it, so I stringify it and then I parse it, it could get parsed into a vanilla object when it was originally some other class. So that's another thing to watch out for with the stringify approach to that, to deep cloning. Okay. Now we're checking the complement. So the complement. I thought it had an I. How do you spell complement? I was today years old when. That's hilarious, dude. I always thought this was like the same spelling as the word compliment, like you tell someone nice. That's hilarious. Yeah, I literally never knew that. There you go. Complement is, so we're trying to get to 0. Minus value 1 minus value 2. Yep. Because that way they'll all add up to 0. Minus value 1 minus value 2. Okay? If complement in scene and scene complement is I. Thanks for the follow. If the scene complement is I, so we have seen the complement, and we are currently in that sort of complement context is what's going on. So we're doing the two sum all the way across for every I, for every number, we're doing a two sum on all the other numbers. And if we're in that current ith context, then we know that the other two are not dupes. So now it's a result. And so we're going to add it as a tuple. That's really crazy. Add tuple sorted. I can't bring myself to do this. It's too squished. Okay, so I'll say cur result. Cur result is sorted. I can do this much. Sorted, val 1, val 2. Unstoppable Coz said, hi, how are you? I'm doing good. Thanks for being here. What language? We're using Python right now. You can see it in the browser IDE. So I'll do sorted, val 1, 2, and complement. Okay. Is that right? Because those are the values, not the indices. Oh, that's what it's asking for. Yep. Okay. So we get this current result. And then we want to res add a tuple of cur result. Why is it a tuple, homie? Why is it a tuple? All right, let's run it. Wrong answer. Is my indentation off? Scene for I val. If val not in dupes, add value 1. J enumerates. Did I misspell compliment? Oh, seen val 2 is I. That's the piece I missed. Okay. Seen val 2 is I. What do we do this? Why do we do this? Let me think about that. Seen val 2. Seen, what is going on? Sort expected 1 argument, got 3. So we're sorting that tuple. Thanks for the follow. Okay, so these are tuples, but they are allowed under list, which is what's throwing me off. What if I do this? Unhashable type list. Unhashable type list. That's the issue. The list is not hashable. That's the issue. How long have you been coding? About 10 years. I code in HTML, CSS, JavaScript, JSON, PHP, TypeScript, React script, Node.js, Python, C++. Cool. Thanks for being here. Okay, so the reason we use a tuple is because the list is not hashable in Python. Okay. But if I cast it back to list, it's going to work just as well, I expect. Yeah. Okay. So so I'm trying to use a hash set right here is the whole reason. Because this has built-in deduplication. I could do this with 3 dictionaries, but it would be just less efficient, I guess. "10 years is a long time. I've been coding for 3 years." Cool. Like I said, thanks for being here. All right, y'all, that's going to do it for today. So 2 problems. We got through 2 problems in 30 minutes. And that's okay. So the first time you try to do the kata, even if you do 1 problem in an hour, that's okay. That's okay. I will say, if you cannot get through a single problem in an hour, go back and do the first 2 sum instead of 2 sum 2. 2 sum 2 is kind of like slightly harder than the ordinary 2 sum. But also, I would be time boxing any of these problems to 30 minutes. So 2 sum 2, even if you were not doing kata, if you were just studying normally, I would say look up the answer after 20 or 30 minutes. Do you stream on Twitch? Yeah, I'm streaming there right now. So I stream to multiple platforms. Link is in the bio if you're interested in that. Also YouTube. And the YouTube video is recorded. So if you want to go back and watch for whatever reason, check it out. Oh, thank God. All right, y'all. Thank you so much for being here. Talk to you later. Oh, and don't forget, you can sign up at ladderly.io. You can sign up for free, learn to code, and you can come join the Discord. See you later.